Find the probability that a point chosen at random lands in the shaded region. Round to the nearest tenth if necessary. So here's our figure, and we have some parts that are shaded and some parts that are not. We have a rectangle with two circles inscribed inside of it. So we have dimensions of the rectangle are 4 by 8, and we're not given anything else. So we're going to have to use that in order to find the area, because the probability will be the area of the shaded over the area of the total. Well, the area of the total figure is quite simple. We have this rectangle. It's 8 by 32. So the area of the total will be the formula for a rectangle's area, base times height, which is, in this case, 8 times 4, which is 32. So that's the area of the total. Now we just need the area of the shaded. Now this is a very unique figure where the shading isn't just one of the circles or half the circles, it's a little bit everywhere. So I'm going to make this a little bit easier. I'm going to, instead of having this be one long rectangle, I'm going to kind of separate it into two squares where we're splitting up the two circles. So first I'm going to look at the area of the square shaded region that are these tiny squares here, 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 and here. They're all equal in area. So if I can find the area of one of them, I can just multiply it by 4. Well, if we look at this one here, this corner, we have the squares going halfway up the height, which is 4. So halfway would make this a 2. Then we have the width, if it's a square, would also be a 2. So it's a 2 by 2 square, making this area 4. So that would be 4 times 4 means so far we have the area of the shaded region. We have 16. 4 plus 4 plus 4 plus 4. Now we need the shaded area over here, these tiny little almost triangles, but not really. It's kind of the shaded area in the small square behind the circle. So we know that that square in total is 4, but it's almost like we're removing that quarter of the circle. So if we could find the area of that quarter circle, we could subtract that from 4 to give us the area of the shaded region. So let's find the area of the circle. The area of a circle formula is pi r squared. So we need the radius. Well, the radius of the circle goes from the center to the edge, so that would be one of these lines here, which is the side length of the square we were talking about before, which is going to be 2. So we're going to have a radius of 2. So we would have 2 squared, which would make the area of the circle 4 pi. Well, that's the area of the entire circle, but like we were saying, the only part that we want is 1/4 of it, the tiny little quarter that is covering the shaded region. So we would want to multiply it by 1/4 or divide by 4 to get 1/4 of the circle. So the area of 1/4 of the circle is just pi. So now we have the area of the little square is 4 minus the area of the quarter circle. To get that shaded region is going to be minus pi. So we have 4 minus pi representing this shaded region here. But there are 4 of them. There's 1, 2, 3, 4 of those shapes shaded in the figure. So we have to multiply that by 4 so that the area of the shaded is going to be, if we distribute, 16 minus 4 pi. But we have to remember we also had 16 from those 4 squares, so we're also going to add 16 to that. So we can simplify that that would be the area of the shaded is going to be 32 minus 4 pi. Now the probability piece, now that we finally have all our areas, is going to be the area of the shaded over the area of the total. So we have the area of the shaded is 32 minus 4 pi over the total, which we said before was 32. So we have 32 minus 4 pi. So we can reduce that we can take out a factor of 4 from the top if we wanted to keep it as a fraction, giving us 8 minus pi over 8, which as a decimal, 8 minus pi divided by 8 is going to give us approximately 0.607, which as a percentage is 60.7%, making our answer choice B.